Also, it should be noted that if you use particular technique or set of classes in your project today, and it worked for you, yesterday or a year ago, it doesn't mean that you can easily expect this to be as successful and work precisely that way tomorrow, right? Because there will be different frameworks, there will be different devices, there will be different environments, and you may be working with someone else, and it just the nature of this business is that you have to constantly learn something, learn, so that it's even if you use something today, you may have to modify it, and sometimes modify it significantly to be successful in a different project tomorrow. So just to be aware of it. So again, don't trick yourself to think, oh, that's easy because I've done X, Y, and Z. Well, another part will be still challenging regardless of that. So of course we do what we discuss here is not like one-page program, but really something of a more significant value, right? So larger scale software. So software is complex, right? Everybody's agree. If you just take a look at your favorite programming language, technical documentation. It's volumes and volumes and volumes. The C programming language, if we take an example of the C programming language, the first K&R, Kernighan and Ricci book that was published in the mid-70s, describing the C programming language, was about probably less than half an inch. If you look at the C programming language edition of today with all the new standards that came out, and the C programming language has evolved, it's going to be close to an inch thick if you look at the book, right? So everything becomes more complex, including programming languages themselves, right? So so the question is, are there any reasonable ideas and approaches to deal with complexity itself? How do you deal with complexity? Something is really complex. You look at this formula, or you look at this database structure, and now you have to write some code which will open this database and somehow be able to extract the data or make updates. And you look at this and you're absolutely unsure to where do I start? How do I validate my assumptions? How do I know that it worked properly? How do I even test it, right? So things can be extremely complex. I tell you that once I had, I already mentioned payroll a couple of times, but once in a company, I had to work with the software was already in production, so big healthcare company was using it, and they had their own proprietary payroll system, which would bi-weekly compute payroll, and the system would crash once in a while. And so I was assigned this task to find what the problem was and fix the problem so that it's no longer crashes. And the complexity there was, you learn about the exceptions, right? You already know about exceptions. The approach to handle errors with exceptions is such that if a non-trivial situation occurs, a software can throw an exception, generate an exception object, and hopefully capture enough information about that exception, and then propagate that exception to appropriate handler, and the appropriate handler does the right thing, and the software doesn't crash. So this is an ideal situation with programming with exceptions, using exceptions to handle errors. In that particular example, in that particular application, payroll computation was essentially a mix of human resource system and payroll in one package. And what was happening there, it wasn't written in Java. It was written in these combination of programming languages. What was happening there, that the exceptions were thrown, but they were designed in such way that they would not even capture the place where the original exception was taking place. And what was happening there, that the system was not really crashing. If the system was crashing, it would be easier to work with, because the crash would tell you, okay, it crashed right here. But what was happening there, that exception was thrown with minimal information. Apparently to the original designers of that software, it was obvious. Everything that was crashing or not working was somehow obvious to these guys. And so they really, there was a way not to capture even the line of code or stack trace where the exception was happening. Instead, the exception ended up being unhandled all the way to almost like the top level of the program. So it would just give you an error message, generic error message, like the program didn't succeed. And there was no more information about anything else. And that was really complex, because in reality, what I had to do in debug mode, setting up multiple combination of breakpoints in that software to try to capture closer and closer and closer to that position where the actual error was happening. And it obviously was related to something, particular employee with that particular set of, settings in the database that was causing some unexpected situation someplace, and the software would just decide to throw an exception, right? And so when the exception was thrown, there wasn't enough information. So it took days and days and days and days to scale it. And by the way, just to mention another level of complexity, there was that the entire payroll run would take 10 hours. So in the duration of 10 hours of computer run, someplace, somewhere, there was this place where one record from the database was causing, exception to happen. An exception was thrown intentionally. But the way it was written, that there was simply, in that situation, no useful information available to where it was happening. So anyway, it just, because of the sheer volume of data and the amount of processing that was taking place, it was taking a very long time to nail it down. And eventually I solved the problem, but it was taking very long time. I don't know, probably weeks, at least 3 weeks of every day, coming to work. This is my job. Find the problem, right? So anyway, there could be other challenges. There could be security issues, privacy issues. There could be all kind of infrastructure limitations, right? There could be situations where problems can be reproduced only on particular systems and not on others. So it's really, even travel can be involved. I mean, the scenario can be really complicated. So most fundamental problem in software is complexity, we say, right? And dealing with complexity, divide and conquer, right? So like I said, have a complex method, split it into multiple methods. Maintain those individual methods individually. If something wrong happens, capture enough information. Example with this payroll, capture at least the information where was that problem originating. Don't ignore that. Of course, the more modern programming languages nowadays give you much more prepared platform to deal with those kind of situations. But essentially, that's why we say, do not over-design your classes, right? The class needs to be small. Small interface. Implementation is a different story, but still it's one class. And then combination of classes is better than having everything written in one class. So, by the way, the great news is that when you divide your problems into sub-problems, computers are very successful at this approach. Computers very easily subdivide long programs into subroutines, subroutines encapsulating with some data with classes, and managing everything from the principles of encapsulation. Software does that very successfully. So that's good news, that this approach works very well, right? If you have a long if condition, like if statement with ton of different subconditions and really complex logical expression, maybe you can subdivide it in two separate if statements. Do this test first, then under that condition do something else. It may not necessarily be a good advice in every situation, but perhaps maybe you're looking for a problem, for a bug. You could do that temporarily, right? So to do everything to separate that offending piece of code into the most isolated part, so that you can then say, okay, that's where it happens. So first you need to identify where the problem, the source of the problem is. And again, starting with all the complexity, you can do some temporary attempts to subdivide even more to keep things manageable. All right. So let's take a break.